All right. Should be close. So, ears, eyes for 15, 20, 30 minutes or so. Okay. Let's talk in general so that you make sure you understand timing, right? In May, you're going to get 6 free response questions. You have 90 minutes to do those 6 free response questions. For some of you, that will be an issue. There are many, I don't say many, if I ever hear of timing being an issue on a test, it's on the free response. It's on the free response, okay? That's why I divide that up into somewhat like 13 minutes per question. Number 6, they want you to take about 25 minutes per question or per that question because it always goes A, B, C, D, E, F, G. It's got a lot of parts to it. We'll talk about that afterwards. I won't talk about that yet. It's always a more difficult type question too. But the first 5 are going to be like one of these. I do think that a inference question takes a little bit longer than 13 minutes if you're going to do the complete write-up. I somewhat think that's going to take you a little bit longer, which, according to the questions that we've done for the 3 classes, allowed or told me that I probably should not put 2 of those on the test. So I didn't. I put 1. I put 1 full write-up on the test, okay? 1 full write-up. It's either a confidence interval or it's a hypothesis test, and it's either 1 sample or it's 2 sample, but it's a full write-up. There are 3 questions. There are 3 questions, but one of them is a full write-up. The other one, I kind of broke it up into sections, so it's not a complete write-up. So you don't have to check the conditions. You don't have to do all the stuff, if that kind of makes sense. Okay? So just timing-wise, I was worried about that. So I just want you to be aware of that. You get all 6 questions at one time. You can work it however you want. If you decide that you don't want to work that question, you skip it, and now you have longer to do the other ones. Of course, if you don't work it, then you're not going to get any points for it. Okay? Every question, 0 through 6, will be a 0, 1, 2, 3, or 4. You'll get 0 through 4 points per question. Okay? The entire free response is worth 50 points. So if you do 6 times 4, that's only 24 points. There is a multiplier. There is a multiplier. So, and it's not quite 2, but it's almost 2. It depends on which question you're doing. We'll talk more about that after spring break. But that's why it's really, really important for you guys to do everything you can to try to get all 4 points, because it's almost multiplied by 2. So the difference between a 3 and a 4 is not just 1 point, it ends up being 2 points. Okay with that? Between 0 and 1. 0 multiplied by is still 0. So you're not going to get any points if it's 0, right? Then they're going to break it up into E's, P's, and I's, and they're going to count E's, and they're going to count P's, and they're going to count I's, and that's going to, depending on how many E's and P's and I's you have, I's won't count to anything, but how many E's and P's you have is you're going to get the 0 through 4. Just kind of understand that's how they grade. That's how they grade. It's a little bit different how I grade. Okay? So let's kind of go over the rubric for chapter 10. Okay? This is the rubric for chapter 10. The very first thing that they always do is give you a model solution, which nobody does the model solution, right? That's like the perfect solution, which, like I said, nobody does exactly the perfect solution. There you can see some work. There's that. There's some conditions. Here's an interpretation. Okay, here's part B. We'll talk about it in a second. But here's how the scoring works. Okay, so this is important for you guys to somewhat understand at least how I'm grading it and then how you're going to get your points. This question is scored in 4 sections. So you never know if a question is scored in 4 sections, 3 sections, 2 sections, 1 section, whatever it might be. It's very seldom just 1 section. This is scored 4 sections. Okay? Section 1 consists of step 1. Section 2 consists of step 2. Section 3 consists of step 3. And section 4 consists of part B. So part A has 3 parts to it, basically. And then part B has 1 part. So those are the 4 sections, if you will. Okay? So here's section 1. Now, you don't have to have all this in section 1. As long as you have it on the paper somewhere, they're wanting you to have these 3 things. These 3 things. Essentially correct if the response includes the following 3 components. So you got to have all 3 of those to get an E. Partially correct if you hit 2 out of those 3. Incorrect if you don't fit the E or the P. So here's what it says. Identifies a 2-sample T interval for the difference in means either by name or formula. And that's now. Up until now, I've pretty much graded that you needed to put both. I wanted you to put the name and the formula. Now I start lacking taking a little bit less than that, and I don't care if you put the name down or you put the formula down. Now there's going to be some notes down here in just a second to help clarify some of this stuff. Notes that random assignment was used to determine which students were given the quarter sheet and which ones were given the 6th sheet. Notes that both sample sizes are large by comparing each sample to a boundary such as n is greater than 30. Okay, so if you hit all 3 of those, you're going to get an E for section 1. If you only hit 2 of those, you're going to get a P, and if you didn't, you're going to get an I. Let's talk about the notes first. Okay, here's some notes just to make sure in case. These are like questions that students always have. So component 1, which was the name, was that the name of the formula? No, that was the 2-sample random. Okay, it is not satisfied if it's, oh no, it was, if it said a 2-sample Z interval. So if you mention Z's, that's not satisfied. That's not going to give you the point, because we all know that means include T's, proportions include Z's. Okay. To adequately address the random condition, the response must include random assignment or equivalent. If the response states that random sampling is a condition, i.e. SRS, or random samples given, component 2 is not satisfied because it was not random samples. You lied, right? Talk all the time about don't lie, don't lie. Random sampling, check. Nope, it wasn't random sampling. You're not going to get the point for that. If the response includes wrong statements about the conditions or additional inappropriate conditions, such as n times p is greater than 10, which I can't imagine anybody doing n times p greater than 10, because n times p greater than 10 is for proportions, and this was not proportions. But if someone happened to do that, which I have no idea how because there is no p, then that's going to be an incorrect statement. The sample is less than 10%. If you did the 10% condition, that's extraneous, okay? Then the response can earn at most a P. So if you put something extra that you're not supposed to put, and it's a lie, for instance, the 10%, you're not supposed to check it. You're not supposed to talk about random sampling. At the most, you can get a P. The most you can get a P. In a statement about hypotheses, again, picture several students taking this, right? Some students might put a hypothesis statement with this, even though it is a confidence interval. Is considered extraneous. Now, extraneous doesn't always count you wrong. However, if such statements included are incorrect, for instance, you put something that's an incorrect statement, then that will hurt you. That will hurt you. So those 3 things to get an E. Here's section 2. Essentially correct if you give the correct 95% confidence interval. And here's something that's really crazy that I have not ever seen, but maybe once or twice. Supporting work is not required. Supporting work is not required. But if it's included, it better be correct.
So on this question, you're better off putting down what's on the calculator, writing nothing else.
Yep. But we did have to say this was a T interval, right? Or the formula. You had to say one of those because of section 1, right? Now, partially correct if you give the correct confidence interval with incorrect but appropriate work. For instance, you might have put the T critical value. If you put the T critical value, but it's the wrong T critical value, you're going to get dinged because that's not the T critical value that produces this interval. Now, if your T critical value is different because you used a different DF, then your interval better be different. Okay? And if that's okay, then everything's okay, it's fine. That's why you have to label things. That's why you have to label things. I'll get you a second, Jeremiah. Or if the response gives an incorrect confidence interval with appropriate supporting work shown, for instance, if an incorrect value is used for the critical value or the standard deviations are not squared, if you did something that really was close, but you just messed up a little bit, however, your interval fits your mistake, you'll get a P. But your interval better fit your mistake. Okay? So you don't square something down here, but you actually get the true critical, or you get the actual interval, that's going to ding you because this formula that you put doesn't work. Okay? Now, incorrect if it doesn't do that. Let's look through some notes. Here are some acceptable confidence intervals along with the degrees of freedom. So if you happen to use DF of 80, then you're going to get that interval. If you use 45, you're going to get that interval. So they kind of give you some different numbers. I don't know why you would use any of those differently because your calculator gives you the DF of 98. Was it 98.8? 98.9. 98.9 or 98.88, whatever it was. Okay? And that's what, just put it down. That's what I do on these guys after I start harping on you guys so much. I write down the name of it. I don't use formulas. But after the name, I put down everything my calculator gives me. Everything my calculator gives me. If my calculator gives me the DF, I put down what DF is. And I don't round it. I don't do anything different. I put down what the interval is. I put down what X bar is. I put down what mu is. Whatever that calculator gives me, that's what I put down. Okay? Just to be sure on that, okay, this was the correct interval, which again, I'm sure if you guys use your calculator correct, you could have got negative 1.879 and positive 4.679. DF was 92.9 or 92.88, but don't round it up to 93. You will get dinged. You will get dinged, okay? If you take it down to 92, you might get dinged. If you don't put it, you're safe this time because the rubric didn't mention that you needed to not put it. Okay? Hey, Scott?
Going forward, so long as we wrote down the name of the test or the name of what the hypothesis earlier, do we even need to be writing down the blank formulas anymore during the calculation section?
It will always say by name or formula.
Yeah, but that's in the hypothesis section. So
I don't put it in the hypotheses. I put it in the work.
Okay. But like, because do we even need it anymore if we just write down every term that's down in the calculator?
We got to still have a hypothesis. Sometimes this one you didn't have to. They'll talk about it in one of these other rubrics, but I mean, as long as you put down everything, you're okay. You really are. The conditions, they're not in your calculator, but you got to get those. Your work, that's why I say, guys, I mentioned it during one of my lectures. One of my lectures, I said the work part of it. Very seldom do students get points off for that unless you lie about it. You put something that's wrong. If you put something that's wrong, you're going to get a point off. But most of the time, the work part of it, very seldom do students get something wrong. They get something wrong because of the conditions. They get something wrong because of the conclusion. They get something wrong because of a ho and a ha. But the work part of it, very seldom do they get it wrong because everybody knows, every AP instructor knows that you're using your calculator to get these answers. And it's okay. We're okay with it. We're okay with it. Just don't put something down that's wrong. And that's why we want you to tell us what the name is. Okay? And then, this is, section 1, we did all that. Here's section 2, we did that. Okay, here's section 3. Section 3. Essentially correct if you fit these 3 components. Uses the phrase 95% confident. We are 95% confident. That's why I beat that in your heads. You got to use that. Or we are 95% confident, or with 95% confidence, something to that effect. Describes the difference in means in context. The difference in means in context. The interpretation is not about the groups, and that's a mistake that a lot of students will do. We can't talk about the groups of the 45 and the 46 and the 54. For instance, we can't say describes a difference in means for the two groups, because that's just talking about my sample. I'm supposed to talk about everybody. And that's why we talk about in people like these. Because these were volunteers. This was random assignment. Okay? Partially correct if you hit 2 or 3 of those, 2 of the 3, or if the response combines a correct interpretation of the confidence level without interpreting a specific interval. Incorrect. Here's 4 notes for this one. A response that includes an incorrect interval is not penalized. So if you get the wrong interval, well, you're going to get it wrong in your interpretation. That's okay. They're not going to ever double ding you for something. They're not going to double ding you for something. Yusuf, I'm not sure you're paying a whole lot of attention, but to each their own. To satisfy component 2, the response must refer to a difference. You must refer to a difference. You must refer to means, and it must be in context. So if you don't mention difference, you're not getting for point 2. If you don't mention means, you're not getting point for section 2. Okay? And that's why I tell you guys to go back into the question and write down what the question says, because most of the time the question says exactly what you need to put. When given the interpretation of the interval and the interpretation of the confidence level, y'all remember there is a level and an interval, right? In the level, it's if we did this over and over again, 95% of the intervals constructed will contain the true difference. If you put that down, it's extraneous, but it better be right. It better be right, because if you put it down and it's wrong, you'll get dinged. If the interpretation of the level is incorrect, it's considered poor communication in terms of holistic scoring. So it's poor communication if you put it wrong. If you only put it, then you're not going to get credit for interpreting the interval. Any interpretation that implies an interval has a 95% chance. Look at that. Any interpretation that implies an interval has a 95% chance is an I. No questions. No questions. Because it never has anything to do with probability. It doesn't have anything to do with a chance of happening. Okay? And we kind of mentioned that several times. I know it's been a while since we've talked about intervals, but we kind of need to get back on that tune because that's what chapter 10 was. Chapter 10 was intervals. Chapter 11 was hypothesis testing. Also, walking around, you guys need to get real comfortable with those calculators. Get comfortable with those calculators. That's why I recommend those worksheets that I gave you. There's 18 of them in there. Just practice with your calculators. Get comfortable with graphing them, plotting them, finding the mean, finding the standard deviation. Get comfortable with that information, because I don't want that to be an issue is why you don't do something. Not knowing how to do it on a calculator doesn't test anything about your knowledge other than knowing how to work your calculator. Right? Nobody taught you how to use your phone. You figured it out. Figure that calculator out. If you need help, by all means, we'll do that. But during test day, right, I don't help. I don't help. Here's section 4. Remember, there's 3 parts, and then section 4 was B. Essentially correct that the response includes the following 3 components. So you got to hit all 3 of these to get an E. Indicates that 0 is in the interval, because 0 is in my interval. States that there is not convincing evidence. There is not convincing evidence of a difference in means, because 0 is in my interval. Make sure we talk about it in context. In context. So we need to make sure we do that, right? Again, here's 3 notes just to kind of wrap it. A response that indicates there isn't convincing evidence that the paper size affects the mean word counts does satisfy components 2 and 3 put together, because it's in context, right? A lot of those get put together. If the response provides an interval that doesn't include 0, so you got it wrong, you put the wrong interval, or You have no idea how to do the question, and so you're going to make up an interval. That's okay. You're not going to get the points anyway. You're not, but you'll get it down here because you have an interval that you're going to, deduce from. So if you have 0 not in your interval, then you have convincing evidence of a difference. That's okay. You'll get full marks for that. You'll get an E. Responses that are equivalent to accepting the null or anything to that effect does not satisfy component 2, right? You can't accept the null. All you can do is fail to reject. So here's how they decided to do this. Now, I'll go ahead. Every E counts as 1 point. Every P counts as a half a point. If you end up with a half, they'll decide holistically. They'll look at the entire thing. So basically picture this, guys, right? 4 points. That's what it's worth. Does this cat understand 100% of it? Understand 75% of it? 25% of it? I guess that's the other way around, but you'll kind of follow that. To decide on. It's hard for a 3.5 to go up to a 4, unless if it's a really, really, really small mistake. But it's not, it's also hard for a half to go down to a 0, because my guess is you understand something. You'll kind of follow that. I don't grade with E's, P's, and I's. If section 1 consists of 3 parts, I'd make it 3 points. And so if you hit all 3 of them, you get all 3 points. If you miss one of them, you get 2 points. If you miss all, right? And sometimes I'll even make them 4 points. 1 a point just for, if you can think of anything statistics, I'll give you something. Most of the time. Most of the time, my free responses are worth 4 points per part, per section, not the entire question. Okay? Y'all good? Kind of okay? Any question about number 10 or chapter 10? Please understand question B, part B. Please understand that question. Chapter 11. It was a hypotheses test. Here's some conditions and calculations. You can see the graphs. You don't have to go that much. I do like to hit trace and just put down a couple numbers just to show that you did it. Y'all follow what I'm saying on that, right? It doesn't have to be a beautiful graph like this, but just 2 graphs. This one's not too bad because you at least have 2 you can somewhat compare to, and it proves that you did it. But if it's just one by itself, which might be what's on your test, you probably at least want to put the median and a couple other numbers just to show where those values are.
So like if I put 2 separate, then I want to put some numbers with them?
Put some numbers with them. Just, again, that's going to be one of those things that they're not going to grade really, really hard. It kind of depends on what the whole thing looks like. If the whole thing looks like crap, but you got that, they're going to give you a little bit. And if the whole thing's perfect and that's a little off, who knows? You kind of follow what I'm saying on that?
And if you were going to like, what numbers would you put?
I just put the medians. Just put the median. And if you got time, I'd put all 5 of them, but it doesn't take long to hit trace and just go to those 5 numbers and just put those numbers down real quick. All right, it doesn't take long. You got 13 minutes to do the whole question. I know time becomes an issue, but okay. They actually drew a normal curve over there. Yeah, we typically don't do that. Here's the conclusion. All right, so scoring. Here's how they did this. This is 3 sections. So this question had 3 sections. So this one gets scored a little bit differently. Normally they try to get 4 sections. They normally try to get 4 sections, but this one's only scored 3 sections. Here's section 1. Hypotheses implies inequality of means for the null and correct direction of the alternative, i.e. indicating that the mean percentage of pop kernels will be larger than the than the name brand. Oh, for the name brand, I'm sorry. So this is where it's important for you guys to label what you're supposed to do, because some of you guys might have mu1 is less than mu2, and some of you might have mu1 is greater than mu2, but it depends on what your mu1 and what your mu2 are. That's why you have to label all that stuff. That's why you have to label it. Both parameters are correctly defined. Mu1 is, mu2 is. As the mean percentage of popped kernels. And this is where they put the name again. The 2 sample t-test for a difference in means is identified by name, or formula. And this one's one of those I really start putting the names rather than the formulas, because the formulas, you got to name it exactly right if you're going to get the full marks. If you mess up somewhere on it, it's going to ding you. Okay? Notes. Now this is interesting too. If the hypotheses are stated in samples, I told you guys that that's really, really wrong. The component 2 is not satisfied. However, component 1 is. So x bar 1 equals x bar 2. X bar 1 is less than x bar 2. It's not going to satisfy component 2 because it doesn't say the true mean or the population mean. However, because you put the equals and the inequality symbols, you will get points for section or part 1 of that. To satisfy component 2, remember that was the definition. The parameter definitions must be in context and include concepts of the mean and population. So you must have the words mean and you must have population, or again, the word that we use all the time is just true. The true mean population. That's indicating it's all of them. Responses that describe sample means as the mean percentage of popped kernels in the 10 bags, right? We don't want to describe those 10 bags. We want to describe all bags. Does not satisfy it. Here's, again, just to kind of look at this. 2 SAMP t-test or equivalent is acceptable. That's acceptable. I really think you should do something like the difference in 2 sample mean t-test. I think saying those type of things give you more ammo. Okay, and I don't think it takes a whole lot to say 2 sample mean t-test difference, right? But again, they accepted 2 SAMP t-test, which is exactly what your calculator says. If the test is correctly identified by name, but an incorrect formula is stated, that's considered a parallel response, and component 3 is not satisfied. So let's talk about parallel responses, okay? Any free response question. If you do this over here and you do this over here and they're the parallel, we are instructed to grade the wrong one. Because you don't know what you're doing. If one of them's wrong and one of them's right, the wrong one's wrong. If the one of them's right, just circle one of them and X out the other one, because you're going to get wrong anyway. Okay? We have to grade the wrong one because, or you have to do it like this. No, you don't know what you're doing. Okay? So parallel responses. A 2 SAMP Z test, Z, if you use Z's, right, is not correct test procedure. Duh. It doesn't say about what happened, so it's just not going to satisfy that component. So don't use Z's with means. Don't use T's with proportions. Here's section 2. This is conditions. Notes that independent random samples of name, brand, and store brand of microwave bags were selected. Again, there's a note down here to help you with that. Checks the 10% condition. Independent observations by noting there are at least 100 bags, or by saying that 10 is less than 10% of all. If you say there's at least 100 bags, then that must mean there's 10 times as many. Checks the normality for both populations. Reports the correct value of the t-test statistic. Reports the p-value. And like I told you guys, right, the work is very seldom considered wrong. There were 5 things up here. Essentially correct if you hit 4 out of those 5. So you hit 4 out of those 5, you're going to get an E for that section. Independent random samples, 10% for both, normality for both, T, and the p-value. Those 5 things. Partially correct if you only hit 2 or 3 of those. If you only hit 1 of them or 0 of them, incorrect. Now, here's where they're going to nitpick a little bit, okay? For component 1, the response must indicate that the 2 random samples were selected. In other words, random check is not sufficient. The words independent is not required. So you don't actually have to say 2 independent random samples, but you do have to mention that there were 2 separate samples, which is why I like to write 2 independent random samples and go off that way and go off that way, just to make sure that they know, understand that there's 2 different ones. For component 2, it is minimally accepted to note that 10 is less than 10% of the population size without specific reference to both. You had to reference both populations. 10% is less than all regular bags. 10% is less than all whatever, not 10%. Was it 10? 10 is less than 10% of all. You got to say it twice. Twice. To satisfy component 3, it must reasonably include graphs, include appropriate comment. Just drawing a graph is not enough. You got to comment about the shape. There are no outliers in either distribution. That's good. The distributions are roughly symmetric. That's good. There's no obvious departures or no obvious skewness. That's good. Or approximately normal. That's good. All of those are okay. You don't have to say all of them, but you had to say something. This is where you can't say large counts condition is met, because this is not large counts. This is not large counts. You had to graph the data. If the response includes incorrect conditions, such as n times p is greater than 10, again, I can't imagine you doing that. However, that's one of the conditions for proportions. Reduce the number of components by 1. So if you did all 5 of them and you did an incorrect one, it's going to reduce it, so it's only going to give you 4. If you only did 3 of them, it's going to reduce it and give you 2. Kind of interesting. Responses that use a 2-sample z-test can satisfy component 4 if z equals and the p-value for z's. If you happen to hit the wrong thing on your calculator or you did z's, you can satisfy 4 and 5. You just can't get the correct name. You can't get the correct name because they've already lost credit for identifying it in section 1. A response that uses pooled, you're not going to use pooled. If the response did not satisfy component 1 because of a 2-sided, right? So basically you did a not equals to, your p-value is going to be different. They're not going to ding you for that p-value. You already got the credit wrong for the inequality being wrong, the alternative being wrong. They're not going to double ding you. Okay. If a response provides a correct test statistic but shows additional incorrect work, such as inappropriate formula, reduce the number of components by 1. So we've kind of learned from this now, after the couple of tests, you're probably better off not putting the formula. You're better off not putting the formula. You're better off putting the name. And that's what, by now, that's what I start trying to teach you guys, is just put the name and put everything your calculator tells you. Put everything your calculator tells you. Because if it tells you what p hat is or it tells you what x bar is, you need to know that. Okay? Sometimes that part is graded. All right. And then here's part 3. Explicitly compares the p-value to the alpha value, because p is greater than, because p is less than. Makes a correct conclusion about the alternative. You either have enough evidence or you do not have enough evidence. They didn't say anything about rejection or not rejection. That's kind of weird. The conclusion is stated in context. So make sure we have enough evidence to suggest, or we do not have enough evidence to suggest the pop bags are better for the name brand than for the non-name brand, or something to that effect. If your conclusion is consistent with the incorrect p-value that you already got dinged for, you'll get credit down here. Because you already got dinged, they're not going to double ding you. Also in context with justification, the conclusion must be about the mean percentage of popped kernels. It must be about the mean percentage of popped kernels to satisfy component 3, unless the response credit is already lost in section 1. If you already lost that in section 1, they're okay with it. The conclusion must be consistent with the alternative hypothesis. So whatever your alternative was, if it's wrong, you're going to get dinged, but they're not going to double ding you. Okay. Just look at this quickly again, just to somewhat understand how you're going to get your points in May. All 3 E's, you're going to get 4. That's the only way to get 4, is you got to get 3 E's. The only way to get 3 is you have to have 2 E's and a P. 2 E's and a P is only going to give you a 3. Now, 2s are weird. 2 E's and no P's, or 1 E and 1 or 2 P's. Kind of bad. So 1 E and 1 P gives you 2. 1 E and 2 P's gives you a 2. Or 3 P's gives you a 2. Minimal 1 E, no P's, or 2 P's. 1 P won't give you anything. Just kind of understand that. Good?